Yo, 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 yo. Here we go. We're going to get after it with key features of the quadratic function. So here's what we're doing. We're looking at quadratic functions. We're going to talk about the axis of symmetry and the vertex. We'll get into those key terms as we go. So quadratic function. Has to be quadratic, means it has to have a power of 2 for its highest degree. So as always, whenever we learn how to graph functions, we're going to start with the parent function, and then we're going to change it around a little bit. So if I'm looking at the parent function of x, f of x equals x squared. If I ever want to know what it is, I can always just plug in values for x and figure out what the y is. So if I were to take the value of negative 2, I'm looking at, well, what is negative 2 squared? Well, 2 times 2 is 4. So that gives me the point of negative 2, 4. So I can plot that here. Negative 1 squared is positive 1, so that gives me the point of negative 1, positive 1. So negative 1, positive 1. 0 squared is 0, so that gives me the point of 0, 0. 1 squared is 1 times 1, which is 1. So that gives me the point of 1, 1. And then 2 squared is 4, so that gives me the point of 2, 4. So 2 and 4. So this would be an example. And this is the parent function for a quadratic function. So a couple things I want to talk about with the parent function. Here's a nice, much better graph of that. First thing is the parent function, or quadratic functions, the name of the graph is actually called a parabola. So the parabola is this graph, it's this shape, and it looks like a U. It is curved, it is not a V like our absolute value function. The reason why is the rate of change is not constant. Like if I look up here, I went up 1 over 1, but then I went up 1, 2, 3 over 1. So it's going to be curved because it's going to increase dramatically more as the further we go up. Now, some key features here are the axis of symmetry. Very similar to the axis of symmetry in absolute value functions. This is the symmetrical line that goes through the vertex, okay, and it tells us, and it shows that the left side is completely symmetrical to the right side, okay. So we always write the axis of symmetry as an equation of a vertical line, which means it's going to be x equals whatever the x value of the vertex is. So a lot of this should sound familiar if you're familiar with absolute value functions. Okay, vertex here is 0, 0. That's that turning point of the graph. Domain. If I had to talk about domain of the graph, domain is all the possible x values of the graph. Well, I could go forever to the left and forever to the right on here. I can pick any value for x and plug it into this graph. And so because of that, the domain of the parent function is all real numbers. Now, if I were to look at the range is what are all the possible y values of this function. So am I able, for this particular function on this particular graph, am I able to plug in a value for x that would give me a y that is less than 0, for example? And the answer is no. I cannot square anything and get a negative number. Okay, it's going to be impossible right now when I just have x squared. Okay, because a negative times a negative is positive, and a positive times a positive is positive. So my range is all the y values have to be greater than or equal to 0, because that shows which way the graph is going. Finally, minimum maximum, that is going to be where is the smallest or lowest, where is the lowest or highest point of this graph. This graph has a minimum. The maximum means going up. It's going to go up forever. So there's no max because it's never going to end going up. But it does have a bottom point. And the bottom is down, and that bottom is at y equals 0. This is the minimum value at y equals 0. It does not have a maximum. It does have a minimum. So these are all the key features of the quadratic functions. We have a domain, the range, we have a vertex, we have an axis of symmetry, and we have a minimum or maximum. And it is called a parabola. It is a U shape. Now, we want to talk about things that might change the quadratic function. So the parent function. So what we're going to do is we are going to look at some tables. I'll fill out one with you, and I want you to do the other one. Okay, we're going to see, well, what happens when I change a value in front of the parent function? So how is this going to impact it? So what happens when I have the a value in the front? What happens if I put a 2 there? What happens if I put a 0.5 there? What happens if I put a -1 there? So we're going to complete our table, and we're going to graph all of these on the same coordinate plane. Okay, so I'll go through this one with you first. So if I have 2 times x squared, that's 2 times -2 squared. Whenever we do this, we have to work on the exponent first, and then I multiply by 2. That's just order of operation. So this is not -4 squared. This is -2 squared, which is 4. 4 times 2 is 8. So that gives me -2 and then 8. So there's my new point. If I were looking at this one over here, this is 0.5, which is just 1/2, right? Well, that's 0.5 times x squared. Well, if I have -2 squared, again, we know that -2 squared is 4, but half of 4 is 2. So that's going to be -2 and then 2. Okay. If I look over here, I have -1 times -2 squared. Well, -2 squared is +4, just like it was here and here. But now I'm multiplying that +4 by -1 to get -4. So that's -2, -4. So here's what I want you guys to do. I want you guys to pause this video and then fill out the rest of these tables. And then I want you to plot all those points on each graph and label each graph as which one it is. And when I say plot, plot all of these points on the same graph, but plot all these ones together, and then you'll make your parabola. Plot all these ones together, make the parabola, and see what it looks like. But then label which graph is which. So pause it, go. Okay, so here are all the points that you should have had. So check to see how you did. And then my next slide, I'm going to go to the next slide right now, and then I'm going to show you what all the graphs look like. So if I plotted all these on one graph, this is what I would have had. Now I do have the parent function here, so I labeled that. So the parent function is here in red. That was the first graph that we started with. And then if we notice, the green one, this is the 2x squared. The blue one is the half x squared, and then the orange one is a -1x squared. There should be a square there, sorry guys. Now, if we notice, there's a couple things that I want to point out here. The graph of 0.5x is wider than the parent function. Okay, or than the graph of 2x squared. The graph of 2x squared is the skinniest of all of them. So this is the one that's increasing at the most rapid rate. And the reason why is that too. Okay, there's the parent function. So if I take a value that is greater than 1 and I plug it in for a in front of the x squared, it's going to make the parabola skinnier. Okay, what it's going to do is it's going to give it a vertical stretch. It's going to stretch it out, vertical stretch, and make it skinnier. If I take the a value and I plug in a number that's less than 1, that's in between 0 and 1, that's a fraction of some kind less than 1, in between 0 and 1, then what that's going to do, that's going to make it wider. Okay, it's going to be a vertical compression. Okay, it's going to make it wider. If I put a negative number in a, it's going to flip the parabola upside down. And again, if we refer to our absolute value function, a lot of this is the exact same process of what we did for the absolute value function. So now what I want to talk about is 4x squared, and I want to talk about over what interval is 4x squared increasing, over what interval is 4x squared decreasing. Okay, so this right here, I don't know where these v's came from. So what I want you guys to do is go ahead and pause the video, and then I want you to plug in these x values into here and create your points, and then we can talk about when we're increasing and when we are decreasing. So we have to fill out the table first, so go ahead and fill this out, and then we'll get into it. So those are the points you should have gotten. You should have got -216, -1,4, 0, 0, 1, 4, and 216. Now, one thing I want to point out is, or not one thing I want to point out, but one thing I want to talk about now is which interval are we increasing and which interval are we decreasing. So the way we know something's increasing or decreasing is we're really looking at the slopes. Okay, and when we look at slope, the slope is the change in y over the change in x. So that's how we look at when are we increasing and decreasing. As my x goes up, so my x's are counting up. So if I go from -2 to -1, I'm really going up 1. That's my change in x. My change in y, though, I go down. And I go down 12. So this is an interval in which it's decreasing. My y values are going down as my x values are going up. But then here at 0, 0, it changes. So right now we're decreasing all the way to here. But then at 0, 0, we have a shift. And after 0, 0, it looks like my y values start to increase as my x values are increasing. So if I were to graph this, it's a parabola. It's not going to be opening downward because it's not negative. So we know it's going to look like this to some capacity, right? This is just a really quick, cheap fast sketch of a parabola on a coordinate plane. I know it's going to be a U opening up. Well, if I look, everything on the left side of the y-axis is decreasing, right? As x increases, this is going down. But then as x increases, this is now going up. So the intervals are when we write inequalities. The interval for which we're decreasing is everything that's less than 0. So for everything that's less than 0, we are decreasing. For everything that's greater than 0, we are increasing. So for decreasing, and I apologize for my bad handwriting, not that it's ever that good, but I don't have my pens, I'm using the mouse. So when we're decreasing, whenever x is less than 0, that is the interval for which this is decreasing. So I know I had the arrow pointing up, so it looks like it's increasing, but if we think about it, we always move from left to right. As my x increases, I am decreasing, so it's going down. This is a negative slope. And it's a negative slope until 0, 0, and then at 0, 0, it starts shifting and it goes up. So over the interval that it's increasing would be x is greater than 0. And that would be for increasing. And I'm just going to leave it abbreviated so I don't have to write it all out. Okay, so those are my intervals because everything greater than 0 is going to be increasing. And it's a positive slope going up. Sometimes you might have to compare average rates of change over a given interval. Okay, so if I'm looking at the interval between 2 and 4, between two different functions, we're going to have to compare the rates of change. Okay, and then figure out, all right, well, what's going on these rates of change in these two different functions. So what I did here is I already graphed it for you because I'm just a really, really nice guy. And then if I look at this function, g of x equals 1.5 times x squared. So here it is. Here are my points at 2 and 4. What I'm doing is if I'm looking for the rate of change, I'm just finding the slope between this interval, between 2 and 4. Well, slope is change in y over change in x. That's 24 minus 6 over 4 minus 2. And this is for g of x. Well, that's going to get me 18 over 2, which gives me an average rate of change of 9 over 1. So the average rate of change over this interval is just 9 over 1. So it's going up 9 every 1. That's not exactly what it's doing, but that's the average. Well, I can do the same thing for the other one. I look at my points at 2 and 4. Well, between 2 and 4, I know that's going to be 4 minus 2, which is still 2. But now I'm doing 12 minus 3, which is also 9. I'm sorry, not also 9, which is 9, which is going to give me 4.5 over 1. I had like my brain froze there for a second. So for f of x, the rate of change is half of what the rate of change is for g of x over this particular interval. It's not like that's going to be the case for all of the intervals, not necessarily, but it is for this interval. Maybe it is for all of them. Okay? And that would make sense when this is half of what's going on for this one. Okay, that's all I got for you guys. So really it's just recognizing the shape, what the a value does, okay, and then it's being able to identify the vertex, the domain, the range, the minimum, the maximum, the axis of symmetry, and then it's also being able to find the rates of change over certain intervals. That's all I got for you guys. No independent practice today. And you know what? I'm not even going to give you things to remember. So that's all I got. Thanks for watching. Good DS out.